Hi guys, today we're going to learn how to find the area bounded by two polar curves. Let's look at this example. They are asking you to sketch and set up the integral expression to find the area inside the graph of r equals 3 sine theta and outside the graph of r equals 2 minus sine theta. Do not evaluate. Okay, so first we need to recognize what's what. We see that this guy that we have over here, this is a circle. Okay, this circle is symmetrical with respect to the y-axis. Okay. This one over here, you can see from pre-calculus, okay, because you learn how to draw polars there, that this is going to be a limacon, okay, a limacon without loop, okay, without loop. That's what we have. These are the two polar. You don't need to know the name, okay, but you can recognize that this circle that you have here, it's over here. This is going to be 3 units, okay, you can see that this is the origin. Okay, and these are 3 units, so that's why you have the circle. On the other hand, you have here the limacon without a loop. Okay, otherwise you can use your calculator, okay, to see the graph. Okay, but here I'm going to draw the axis so you can see how the symmetry is working beautifully here. Okay, so now you have, technically speaking, this one is a 3 unit circle. Why 3? Because you can see that it's 3 units. Anyway. Okay, you don't need it. Okay, I did it because that's how I work the computer. Anyway, so what are you going to do? Recognize what they are asking for. Okay, so they are asking for which area. They want the area that it's inside the circle, okay, but outside the limacon without a loop. So what they want, okay, is going to be from here. Okay, I'm going to pretty much draw the border here. Okay, so that's the area that they want. Let me draw it so you can see it there in your computer. This is the area that they want. Okay, so you are all happy, you are like, okay, so that's the area that we want. Now think about algebra 2. What we were looking for when two curves or functions back in the day were intersecting. Here they are curves, right? So you wanted to find the intersection points. Okay, so we want to find where they are equal. So the first thing that you need to do in this situation is going to be set your two, okay, curves equal. So what we're going to do is you are going to let, okay, your 3 sine theta to be equal to 2 minus sine theta. Okay, where are we getting them? From the hypothesis of my problem. After that, what are you going to do? You see that this guy and this guy, they are like terms, so you pass adding this one to the other side. Okay, so I'm going to work it here. 4 sine theta is equal to 2. You divide both sides by 4. And you have a friend here. Okay, you're going to tell me, oh, should I find all the solutions, infinitely many solutions for this one? No, you can see that technically speaking we're in the unit circle. Okay, so just solve it for the values, the friendly values of the unit circle. If you know your unit circle here, when sine of theta is equal to 1/2, you know that this happens to spots pi over 6 and 5 pi over 6. Okay, so you can see that this is in quadrant 1, this guy is in quadrant 2, nothing surprising. So you can see that this is going to be pi over 6 and this is going to be 5 pi over 6. Now think about something. Remember, in polars you are going to have, this is your initial point, okay? So imagine that this toothpick, okay, is, here is my pi over 6, okay? So I want from pi over 6 up to 5 pi over 6, okay? So that's what we want. Okay, let me draw the pi over 6 here, angle, so you can see it. Okay, so this is, I'm going to draw it, pi over 6, and this one over here is a 5 pi over 6. Now, here the business is that polars, they are not rectangular coordinates, okay? So what you're going to do is this radial lines that we have from here to here, okay? We're going to sweep them. Okay, so what are we going to do? We start at pi over 6, okay, and we finish at 5 pi over 6. So those are going to be your limits of integration. Isn't that beautiful? Now, what are we going to do? First of all, okay, you are going to tell me, okay, so area 1, I'm going to find area 1. What's going to be area 1? If I just put, okay, the, let's say that you start with the circle, okay, from here to here, you're also going to include this part. Do you agree with that? So let me draw that one. It's going to be the integral and 1/2 because that's going to be your formula for the polar, okay, area. So it's going to be pi over 6 to 5 pi over 6, and then you have that it's going to be the circle 3 sine theta squared d theta. That's going to be including the part that I have shaded, but we don't want this, basically this shaded line. Do you agree with that? What we want is only the pink part, okay? So we need to remove the shade. Area 1 is practically all of this, okay? All of this, okay? All of that, okay? But I want to remove, okay, this area that I have here. Let's call it area 2. So area 2 is going to be equal to 1/2 integral from pi over 6 to 5 pi over 6. And this is going to be, okay, the border that you have. Imagine that you have the toothpick here, okay? I want the border to be only the limacon without loop, okay? So I want this radial line to last only until you have this limacon without a loop, okay? So if I'm declaring my border as this one, I need to put that r as my original r of the integral. Do you see it? Okay, so this part is going to be the gray part that we have here, okay? So my total area, my overall area, okay, total, okay, the pink one, okay, I'm going to call it pink, okay? It's going to be equal to this, which is going to be the whole thing, minus this one, okay? So you have 1/2 integral this, okay, 3 sine theta squared d theta minus, okay, 1/2 integral pi over 6, 5 pi over 6, and then here you have the 2 sine theta squared d theta, okay? So then we have exactly the pink area that we have, okay? So hopefully this makes sense for you. Please remember that we are first, this one that we have, it was the entire area here, and then we just wanted to remove this one, okay? Do you see it? And that's going to be the area of the pink situation that we have over here, okay? So let's move on to the next. For this example, they ask you to sketch and set up the integral expression to find the area of the common interior of r equals 3 cosine theta and r equals 1 plus cosine theta. So similarly to the previous one, you can recognize that this is also a circle, but this is symmetric with respect to the x-axis. And this is going to be a cardioid, okay? So a cardioid, okay? So that's the big difference here. Here I drew them for you. Let's draw the axis so you can see what's the business, okay? Okay, so that's the x-axis, and we're in the polar plane, remember. Okay, we're not in the Cartesian plane, we're in the polar plane. Now, what do you have? Remember, in the polar plane, you are always starting here at the origin, okay, and you are starting in between quadrant 1 and 4. Okay, so your windshield wiper or your toothpick here is going to move like this. Okay, it's not like you can move it however you want. It's very old-fashioned. Okay, so you move it like this. So let's look at the area that they are asking for. They want you to find the common interior. The common interior, let's draw it. Okay, it's going to be this area that seems pretty easy to recognize visually, okay? Okay, so we have that it's going to be this area that we have over here, okay? So that's going to be the area that we have. The problem that I see is that it's in quadrant 4 and 1, okay? So we have two options. Either you use the negative angles or you start at 0. I'm going to use symmetry so you can see another way of solving the situation. The first thing that you are always going to do when you have two polar curves is see when they intersect each other. You can see it visually that it's here and here, but we're not going to guesstimate, okay? I'm just going to make sure that we find the correct values, okay? So you are going to let your 3 cosine theta to be equal to the 1 plus cosine theta. Again, you can see that these two, they have like terms, so I move the cosine to the other side, subtracting. So what you have here is going to be what? You pass it subtracting, so you have that this is going to be cosine theta is equal, okay, 2 cosine theta is equal to 1. Okay, so you have that cosine theta is going to be equal to 1/2. Do you see it? And you can see that this is another user-friendly angles because you know them from the unit circle. Okay, so from the unit circle you have that it's going to be pi over 3, okay, which you can see that it's this guy, and then 1 in quadrant 4, which is going to be your BFF from pre-calc, 5 pi over 3, okay, so which is going to be this guy that you see, okay. So now you're going to tell me, oh, are those the limits of integration? Well, wait, because if you move like from here to here, you're going to be moving from here to here, and that's not the area that we want, okay, because remember, our windshield wiper or your toothpick is a very old-fashioned situation, so it doesn't move like here, like this. It always moves, okay, like a regular angle from geometry, okay, from the origin here, okay, not the other side, okay. So what are we going to do? What you can do is you start at the origin and you stop here, okay, and then you use symmetry. But the issue that we have, we draw it, you can see that pi over 3 is this is pi over 3, okay, and then we have a similar situation for 5 pi over 3, okay, which is this one, okay, do you see it? Okay, so now what you can see is that I need to split my situation in several pieces. Let's say that I'm going to only use quadrant 1. I'm only going to work with quadrant 1 in this situation. I'm only going to work with quadrant 1 and I'm going to use symmetry. Okay, so if I try to find the area from here to here, okay, what do you have? Your limit of integration, that area, is going to be 1/2 integral from 0 to pi over 3, okay, and what's going to be your border, the border of the toothpick? This one. What is that one? That one is the heart. Okay, that's the cardioid, so it's 1 plus cosine theta squared d theta. That's how I decided. I'm seeing what is the border of the pink region. This one, which is the heart. Are we okay with that? So this one, I'm finding all this area, but I'm missing this little piece here. Do you agree with that? So that's incomplete. I also need to find that piece that it's here. How can I find it? I know that it's 1/2 integral of something, and this guy, the border of that one, okay, when I move from here to here. What happens when we are moving from pi over 3 to the rest? If we're moving from here to here, which is pi over 2, why do we know it? Because you know your unit circle, okay, from here to here, okay. So this one is going to be pi over 3 to pi over 2. Are we okay with that? Why pi over 2? Because that's a quarter, okay? That's where quadrant 1 ends, okay? And what's going to be your border? Your border is going to be this curve. If you see that curve, that's the circle. So you have that that's going to be 3 cosine theta squared d theta, okay? I'm going to call it star and this one double star. Area of star is going to be this part, and area of double star is going to be this part. But that's only half of my figure. Do you agree with that? So what's going to be the total area? The area of the total situation is going to be 2 times, okay, the first one that we have over here, 0 to pi over 3, 1 plus cosine theta, all of this square d theta, plus 1/2 integral from pi over 3 to pi over 2, 3 cosine theta square d theta, and we finish with this, okay? Do you see it? Okay, you're going to tell me how in the world you find the pi over 2, because visually you are going to do, okay, the windshield wiper starts there, okay, because that's where we stop, okay, and it ends up here, okay. You are covering this pink area, and the way that you are telling pretty much the windshield wiper to stop in the circle and not continue with the cardioid is by putting the circle as your integrand. Do you see it? Well, of course square, right? But that's why we're using the circle as your border, okay? See it as a border, okay? Because this is telling you how long is your in this case the toothpick. Do you see it? Okay, so hopefully this makes sense for you. If not, write it in the comments. I can work more problems for you, and I hope that you find this video helpful. Bye.